If x raised to the power of 10 is equals to 5 and x raised to the power of 9 all divided by y is equals to 5,555, what is the value of 1 over x times y? So how can we solve for this in this problem? By the way, feel free to pause the video and try to check this question out yourself, and after that you can unpause it in order to see the solution. So what are we to do in the first place? Let's focus on this side of the equation. It says that x raised to the power of 9 all divided by y is equals to 5,555. However, we are given something like x raised to the power of 10 to be equals to 5, a constant value. Now, let's use some of the knowledge of indices. In indices, when you have two base to have an index, it's not necessary for the index to be the same. Let's say A to be connected with a division sign. Then you can typically select one base and subtract their power. If that is the case, I want to do something similar to this x raised to the power of 9, which implies that x raised to the power of 9 can be expressed to x raised to the power of 10 minus 1. This makes sense. And if that's the case, I can distribute the base. So which implies that this will become x raised to the power of 10 divided by x raised to the power of 1. So therefore, what I'm going to do right now is just to replace x raised to the power of 9 with x raised to the power of 10 divided by x raised to the power of 1. Right now I can now have x raised to the power of 10 divided by x raised to the power of 1 all divided by y to be equals to 5,555. Perfect. So what are we to do next at this point? So what I'm going to do right now is to replace x raised to the power of 10 with 5 as given. So therefore, this returns out to be 5 divided by x raised to the power of 1, which is x, then all divided by y. And that's going to be equals to 5,555. Perfect. Now let's use the concept of keep, change, and flip to simplify this compound fraction. So this fraction at the left hand side can be rewritten as 5 over x then divided by y. And this is going to be equals to 5,555. So eventually this should be 5 over x then multiplied by 1 over y. And that's going to be equals to 5,555. So multiplying that, we should eventually have, okay, let me create just some more space. So that should be 5 over xy. So now be equals to 5,555. So what I'm going to do right now is just to cross multiply. And this is as if it's divided by what is divided by 1. If I cross multiply, then I'm going to have 5 to be equals to xy multiplied by 5,555. So at this point, since my main goal is to isolate xy, so I'm just going to divide both sides by 5,555. So right now it turns out that xy will now be equals to 5 over 5,555. But don't forget, our main goal is to have 1 over xy. So what are we to do at this point? What I'm going to do right now is just that I'm just going to find the reciprocal of x times y. The reciprocal of xy is simply equals to 1 over xy. And since xy is equals since xy is equals to 5 over 5,555, then 1 over xy will simply be equals to 1 over 5 over 5,555. I hope you got that. So therefore, 1 over xy will simply be equals to 1 over 5 over 5,555. And eventually, 1 over xy should be 5,555 over 5 after using the concept of keep, change, and flip. So right now, if we divide this, we should have 1,101. And this is the final solution to this problem. Hopefully, you find this helpful. If you haven't subscribed, please do subscribe to my channel. Thanks for watching. See you guys in the next video. Bye for now.